In this video, we'll talk about Precursor, which is a full protocol aiming to solve the alignment problem. We'll look at specific concerns Vanessa worries about in the alignment problem, how Precursor aims to deal with these, as well as some potential concerns about Precursor. The purpose of this video is to see an application of Infra-Bayesianism and Infra-Bayesian physicalism, showing how it could be used to form an alignment protocol. Specifically, we're hoping this video illustrates a connection between the mathematics used in Infra-Bayesian physicalism and how this can be applied to alignment. It is unlikely that what's said here will remain true to Vanessa's future views on how to set up such a protocol, since Vanessa is still working through the arguments. Vanessa will likely write up a post about Precursor when she has thought more about these ideas, and you should refer to that if your goal is to understand Vanessa's alignment protocol. Precursor is a protocol that aims to solve the alignment problem. Specifically, the goal is to come up with a way to create an AI that is both inner and outer aligned. As a couple of examples of outer alignment failures which Vanessa is worried about, firstly, the AI could hack its input channel, changing its inputs so that the world looks great according to its utility function, even though this isn't true. For example, if an AI views the world through some camera, it could hack that camera to show the world being filled with people having a great time, whereas the real world, things could be very different. Secondly, Vanessa is worried about the AI having incentives to change the preferences of its users, making them easier to satisfy. For example, if your preferences involved seeing humans flourish, it will mean solving lots of really difficult problems. It would be much easier if you enjoyed sitting at home watching television, and so the AI is incentivized to change your preferences to make it easier to make you happy. In thinking about inner alignment, Vanessa is thinking about issues of Acausal Attack. Vanessa sees Acausal Attack as a special case of maser optimizers. If you are unfamiliar with the terms maser optimizer and inner alignment, we would recommend watching the Robert Miles video on these topics. We'll link these in the video description. We'll go into a bit more detail now about Acausal Attack, since it's going to be particularly important later. Okay, so what is Acausal Attack? The idea was originally proposed by Paul Cristiano. It's a weird problem that seems a little absurd upon first hearing about it, but it is hard to rule out, and several alignment researchers have scrutinized these arguments and still consider this a potential concern. We mentioned earlier that bridge rules can make good hypotheses very complex, which is bad due to the importance of the simplicity prior. One side effect of this is that simulation hypotheses can start to look more attractive. Basically, the bridge rules make the world complicated, and the AI could reason, what are the chances the world is actually this complicated? Maybe this is a simulation, and it's complicated for specific reasons to influence the AI, and the real world outside of the simulation is nice and simple. The AI might then reason about these powerful agents or attackers that created the simulation, and reason about how they might reason about the AI. And it may lead to the AI reasoning about deals it can make, and which ones the powerful agents will consider in their world. This is called an acausal handshake. As an example, the AI might become convinced that if it doesn't do some specific action, for example, make another AI to replace it with a different utility function, really bad things will happen. And if it does, really good things will happen. This will be bad since we wouldn't know what the utility function would be, and it could present a threat to humans. Okay, so those are the problems. Now let's talk about Precursor. Given a hypothesis, Infra-Bayesian physicalism gave us the ability to tell which programs are running, and also to tell if a program is an agent along with its utility function. We can use these for the following protocol. Firstly, precursor detection. For each hypothesis in the prior, check which agents are precursors of our agent according to that hypothesis, and we'll define what precursor means in just a second. Secondly, classification. Among all the precursors, check whether any of them are definitely not human, animal, or previously created AIs. If there are precursors like that, discard the hypothesis. If there aren't, then decide which precursors are human. Thirdly, assistance. Follow an aggregate of the utility functions of the human precursors, using value inference to infer their utility functions. Where by value inference, I mean the process of deducing a utility function that we described in the physicalism video. We'll now talk about each of these steps in more detail. Okay, so let's start with precursor detection. First, we need to define precursor. An agent H is a precursor of our AI G in some universe when there is some policy that H can follow, such that applying the counterfactual H follows that policy causes our AI to not exist. So precursors are agents that could have followed a policy that caused the AI to not exist. As an example, if when designing the AI, my cat could have jumped on my keyboard and destroyed my hard work, then the cat would count as a precursor. No acausal attackers will appear as precursors, since they can turn off the simulation. When we found a precursor program, we can extrapolate it to make the full agent. We need to do this since there could be many programs that have the same output on a specific set of inputs that we're considering. We can extrapolate to new inputs, for example, by selecting for the programs using description length, meaning we choose the shortest program, There are other alternative ways, but Vanessa is still thinking about which one could be best. Okay, so that's how we detect the precursors. Now we want to go about classifying them. We want to classify our precursors into 3 different types. Benign, so things like humans, malign, so things like Acausal attackers, and irrelevant, things like animals or other AIs. There are a few things we can take into account when trying to do this. Firstly, we probably need a rough neuroscience-based model of humans. This doesn't need to be perfect, but will need to incorporate brain-specific properties so that we can classify humans reasonably well. We also probably know lots about the current AIs that are around, like their source code, and so we should be able to classify them quite easily. We can also use our intelligence metric G, since Acausal attackers are more likely to be very intelligent. We can thus implement some sort of intelligence cutoff and treat unclassified precursors above this cutoff as malign. Anything outside of safe AIs, our neuroscience model, or the intelligence cutoff could be a malign simulation hypothesis, and so we throw those hypotheses away. Okay, so let's talk about assistance. If the classification step went well, we should have discarded all the hypotheses that contain malign precursors. We now need to pick the utility function of our AI. One way we could do this is to make it simply the utility function of the user, meaning the person who causally created the AI, and we can determine this using mutual information arguments.
And for example, what I'm doing in Predka is I'm saying, okay, so we know which programs are running, we know which of them are agents, so we know which agents exist in the universe. Now we only need to decide, and we know what their loss functions are, so only remains to decide who of those agents is the user, and then we need to follow the user's utility function. And to decide who of those agents is the user, we use this notion of causal relationships between agents, and in some sense, the agents that closest to me, in the sense of like causal links, is the user, and that's basically it.
Alternatively, we take some aggregate of all the utility functions of the benign precursors, meaning an aggregate of all the utility functions of all the humans around at the time the AI was created. The AI will then pursue this utility function out in the world. Okay, so now we can think about whether this protocol solves the problems we talked about earlier. We can start by talking about outer alignment. Our utility function is constructed by aggregating the utility functions of all the humans that are precursors of the AI. This resolves the issue of our AI trying to modify humans, since the precursor humans are fixed, and so the AI has no incentive to change people's preferences. The AI is probably even disincentivized from this if the precursor humans don't want it to.
There where the way we infer the utility function of the user is by looking only at its past and not in its future, like the computation that already ran, not the computation that's going to run. And this kind of, in one fell swoop, solves us the big problem with daily learning, where AIs get motivated to hack the input channel or get motivated to hack the user itself or something like that.
We also avoid hacking the input channel related arguments, since our agent picks from a bird's eye view, since it's an Infra-Bayesian physicalist, so there is no specific input channel for it to hack. So what about inner alignment? Note that our AI doesn't train a policy. It instead trains a model and then uses this model to get a policy. Vanessa suspects the second step can't produce Maser optimizers, since it only involves what's called a control problem, as opposed to the agent doing any sort of learning. This decision to train a model first rules out a lot of the traditional ways that Maser optimizers could arise. Hence, Vanessa sees Maser optimizers as coming from the hypothesis, and Vanessa believes that if a hypothesis contains a Maser optimizer, it will come from an Acausal attack. Fortunately, we should be able to catch these with our filtration mechanism that we implemented in the classification step. So why might this not work? Vanessa has given a few ways that she can see this method breaking down. Firstly, implementing a good enough classifier might not be feasible. For example, we needed a rough neuroscience model for humans, and that might actually be very hard to construct. Secondly, the definition of precursor might have conceptual holes and may require some formal work to pin down. Thirdly, we have a bit of a weird one. Aliens could be false positives in our filtration system that we implement during classification, meaning our AI won't filter them out, and they will influence the final utility function that the AI has. Fourthly, maligned AIs could create false users to influence the utility function that our AI eventually ends up with, since when we aggregate, having extra users will change the final utility function that it lands on. Fourthly, our AI might stop deferring to users any more than the resulting utility function demands, if it is confident in its detection and classification steps. As I mentioned in the beginning, Vanessa is still thinking about Predicate and working through the mathematics as well as the conceptual theory. And so it isn't surprising that she has more concerns at present than she does for some of the other things we brought up in this video series. So where should you go to find more resources on Predicate? As I mentioned off the bat, there aren't many resources out there to learn more about Predicate. But one place you can go is Vanessa Kosoy's Shortform. Just look for the word Predicate and you'll find more information about Vanessa's ideas there. Vanessa has also given a presentation that you can find on YouTube, which has more information about Predicate. We'll put links in the description for both of these. So in conclusion, Vanessa and Diffractor have created Infra-Bayesianism, along with its applications that we've talked about in the last two videos, to deal with some of the major problems that arise in standard reinforcement learning that could prove critical to solve alignment. Vanessa has lots of other things she thinks are important, for example, traps within the environment, that we didn't really cover in detail, but were referenced by Jack when discussing Vanessa's research agenda. We hope this video series has provided enough information for you to understand how Infra-Bayesianism works at a conceptual level and why Vanessa and Diffractor see it as significant. Infra-Bayesianism is still a young field with lots of room for more research. For those of you who are interested in learning more about Infra-Bayesianism, either by getting into the mathematics or still at a conceptual level, we have a few resources that we would recommend. Jack and I, along with our mentor Diffractor, created a problem set that works through a key mathematical result in the development of Infra-Bayesianism, called the Fundamental Theory of Inframeasures. This resource goes into the technical weeds of Infra-Bayesianism. The original sequence by Diffractor and Vanessa includes all of the technical details about the mathematics of Infra-Bayesianism, if that's what you're looking for. For slightly less technical resources, we recommend Adam Sheemy and Thomas Larson's distillations, with the former being more technical than the latter.